Okay, so we're going to prove that for a and b containing the real numbers, a is equal to b if and only if for every real number epsilon bigger than 0, it follows that the absolute value of a minus b is less than epsilon. So notice this statement is in the form p if and only if q implies r, right? Where of course p is a is equal to b, q is for every real epsilon bigger than 0, and then r is absolute value of a minus b is less than epsilon. So remember, for if and only ifs, we have to first do p implies the conclusion, which is q implies r, right? But we're going to use a logical equivalence here, and we're going to use P and Q implies R. So if we can prove P and Q implies R, then it's the same thing as if we were proving P implies Q implies R. Okay? So we're going to assume that A is equal to B, and that for every epsilon, epsilon is bigger than 0. And we want, assuming these two things, we want to get to that the absolute value of A minus B is less than epsilon. Well, if we have A is equal to B, we know that A minus B is equal to 0, right? Or we know that B minus A is equal to 0, right? The first one, we subtracted B from both sides to get A minus B is equal to 0. And the second one, we subtracted A from both sides to get B minus A is equal to 0, right? And then this gives us that A minus B is equal to 0, or negative A minus B is equal to 0, right? Notice that b minus a is the same as negative a minus b, because negative times a is negative a, and negative times negative b is positive b. So b minus a is the same as this. And the reason why we did that is because this is the definition of absolute value of a minus b is equal to 0, right? And of course, we assumed that epsilon was bigger than 0, so epsilon is bigger than this. So this implies that the absolute value of a minus b is less than epsilon, which is exactly what we wanted to prove, right? It follows that absolute value of a minus b is less than epsilon. So we proved it the first way. Now we got to prove it the other way. We have to show that, let's give myself some room. We have to show that Q implies R implies P. But what we can do here is we can do this way by contradiction. So remember, for contradiction, we assume the negation of the statement. And in assuming the negation of the statement, if we can arrive at a contradiction, that means the original statement here must have been true. So remember, the negation of this statement is logically equivalent to the negation, Q implies R and the negation of P, right? So this is logically equivalent to this. So if we can get a contradiction here, right, that means that this original statement inside of here has to be correct because the negation was not correct. Okay, so Q implies R, so we're going to assume for every epsilon is bigger than 0 implies that the absolute value of a minus b is less than epsilon. Remember, that is the Q implies R. And remember, P was a is equal to b. So the negation of P would be a is not equal to b, right? Okay. So we know that a not equal to b implies that a minus b doesn't equal 0, or b minus a doesn't equal 0. Same argument as before. Of course, this implies that a minus b doesn't equal 0, or negative a minus b doesn't equal 0. And these two together imply the absolute value of a minus b does not equal 0. And the absolute value of anything is positive. So this means that the absolute value of a minus b has to be bigger than 0. So remember, we chose epsilon, any epsilon, to be bigger than 0. So if absolute value of a minus b is bigger than 0, that means, this implies, there exists an epsilon naught, just signifying there exists some epsilon, right? Where we have epsilon naught is equal to the absolute value of a minus b, because this is bigger than 0, right? From our argument, right? So we know there exists an epsilon, right? Some epsilon that is equal to this absolute value of a minus b, because we know that epsilon is always bigger than 0. But notice we're saying that every epsilon bigger than absolute value of a minus b, but we have here that epsilon naught is equal to the absolute value of a minus b. So this gives us that epsilon naught, right, is equal to the absolute value of a minus b, which is supposedly less than epsilon naught, right? Because it's supposed to be less than any epsilon. You can't have epsilon naught be less than epsilon naught, and that is our contradiction. Okay, so that shows us that this original statement here, without negating it, must have been true. So we've proven going this way, and we've proven going this way. So we've effectively proven the if and only if statement.